Good morning to everyone. Myself S. Tamilarasu, Assistant Professor, Department of Computer Science and Engineering, Hindustan Institute of Technology, Coimbatore. Today I am going to present the subject as that is the course code is 22 CS 402. Subject name is Computer Architecture. Let's see about the course objectives. The first one is to study the concept of basic structure and operation of a digital computer, and then to impart the knowledge about the operation of arithmetic unit, including the algorithms and implementation, addition, subtraction, multiplication, division, to know in detail the different types of control and the concept of pipelining. The fourth one, to know the hierarchical memory system, including the cache memory and the virtual memory. And the fifth one, to acquire the knowledge about the diverse ways of communicating with I/O devices and standard I/O interfaces. These are all the course objectives which will be discussed in the computer architecture subject. Next one, course outcomes. The first outcome is identify the basic structure of a digital computer and instruction sets with addressing modes. Course outcome 2, comprehend the arithmetic operations of binary number systems. Course subject outcome 3, recognize the organization of the basic processing unit and examine the basic concepts of pipelining. Course outcome 4, infer the process concept by introducing the multi-core cluster, shared and distributed architecture concepts. Course outcome 5, express the standard I/O interfaces and peripheral devices. Next, we will see about the topic as secondary storage memory. The purpose of having the secondary storage is we will use the data for future usage. We have derived any kind of data from the stored information. So whatever we want, we need to extract the specific information from the stored content in the hardware, hard disk or compact disk or DVD or USB drive or memory card, whatever it may be. So the purpose of accessing the information in future, we require the secondary storage devices. The secondary storage devices store the memory instructions permanently, and it is a non-volatile, and it provides the backup storage for the data and instructions. So example of secondary memory devices are magnetic tape drives, magnetic disk drives, optical disk drives, and magneto-optical disk drives. So these are all the listed number of storage devices: magnetic tape, magnetic disk. Magnetic disk includes floppy disk, hard disk, zip disk. Optical disk includes read-only optical disk, that is compact disk ROM, read-only memory, DVD ROM, digital versatile disk, read-only memory, and recordable optical disks are compact disk read, compact disk read write, digital versatile disk read, and the fourth one is the magneto-optical disk. The next one is magnetic tape. The sequential storage devices. A tap needs to rewind or move forward to the location of the data, and a storage medium on a larger open reel or in a smaller cartridge or cassette, which was the traditional uh, way of playing the songs in the past 20 years back. We generally used these kind of cassettes, and they are durable, written, erase, and rewritten. It is not suitable for the data files which are updated frequently. So generally these are used to store the backup data which are not used often. So whenever we require the data, we need to play the cassette, and we have to get it from the information from the tape. This is the example of magnetic tape. The left side indicates the 10.5-inch reel of the 9-track tape. The right side indicates the how a portion of a magnetic tape is represented. The column wise represents frames A, B, and etc. And the row wise represents the number of tracks, track 1, track 2, or whatever it may be. So magnetic tape is divided horizontally into 7 or 9, vertically into frames. Here, the gap between the every record will be uh, represented to continue the data processing. So the data is recorded in the form of blocks. Each block is read continually. There is an inter-record gap between two blocks which provide the efficient access of the information which are stored in the tape continuously. That is, without break, we are able to hear the audio or video, whatever may be. We need to, we have the ability to clearly identify the information which are stored in the magnetic tape. This provides the time for the tape to be stopped and started between the records. It provides the frequent gap between the records for the smooth continuity of the accessing information. The features of magnetic tape are inexpensive storage device, and it can store a large amount of data, easy to carry or transport, not suitable for random accessing data, and it provides a slow accessing device, and it needs the dust prevention as dust can harm the tape. So it is suitable for backup storage or archiving. The next one, magnetic tape. Magnetic disk is a direct access secondary storage device. It is a thin plastic or metallic circular plate coated with the magnetic oxide and encased in a protective cover. So data is stored on magnetic disk as a magnetized spots. The presence of magnetic spots represents the bit 1 and its absence of the bit represents 0. This is the pictorial representation of the magnetic disk. The circular represents the track, and the in between lines represent the sectors. The very first information is stored in the outside, and the last information is stored inside the track. The surface of the disk is divided into concentric circles known as tracks. The outermost track number is 0, and the innermost track is the last track. So tracks are further divided into sectors. A set of same tracks on all disks forms a cylinder. So the read-write head is positioned to the desired track where the data is to be read from or written into. The time taken to move the read or write head to the desired track is called the seek time. Once the read-write head is at the right track, then the head wait for the right sector to come under it. The time taken for desired sector of the track to come under read or write head is known as the latency time. Once the read or write head is positioned at the right track and the sector, the data has to be written to the disk or read from the disk. The rate at which data is written to disk or read from the disk is called the data transfer rate. So accessing time of disk equal to, which will be found by consolidating all the three things, seek time plus latency time plus data transfer time. So these are all three combined as the accessing time of a disk. So the features of magnetic disk are cheap storage device. It can store a large amount of data, easy to carry or transport, suitable for the frequently read or write data, fast accessing device, and it is more reliable storage device to be prevented from the disk as the read or write head files over the disk. Any dust particle in between can corrupt the disk. Examples of magnetic disk are floppy disk, hard disk, and zip disk. So floppy disk is a flat, round, and a single disk made of the mylar plastic and enclosed in the square plastic jacket. FDD is the disk drive for floppy disk. The floppy disk is inserted into the floppy disk drive to read or write the data. It has a protect slide tab that prevents a user from writing to it. A floppy disk may be a single-sided or double-sided. It can be read and written on one end and both sides of the pocket respectively. This is an example of floppy disk. And is small when compared to the CD drive. It can store the minimum amount of data. The next one is a hard disk. It can store, there is more number of platters are divided into concentric tracks and sectors. Mounted on a central spindle, it can be read by the read or write head. The data stored in the plate is covered with the magnetic coding. Hard disk is a fixed. The disk is not movable from the drive. This is an example of hard disk. This is an example of hard disk. The center thing is represented as a spindle which can hold the platters. The circle represents the tracks. The accessing arms hold the read or write head. This is zip disk. They are the high capacity removable disk. It have the speed and capacity of the hard disk and portability of the floppy disk. The zip disk are the same size of the floppy disk, that is 3.5 inch, but it have a much higher capacity in the floppy disk. The next thing is optical disc. It is a flat and circular disc which is coated with the reflective plastic material. It can be altered by the laser light. Optical disc does not use the magnetism. So the bits 1 and 0 are spots as they are relatively bright and light respectively. The tracks on optical disc are further divided into sectors which are of the same length. So the sectors near the center of the disc wrap around the disc longer than the sectors on the edges of the disc. This is an example of a magnetic disc which is represented in the left side. The pictorial representation of the optical disc is represented as the right side. So here the magnetic disc having the tracks and sectors. The sector length may be varied in the magnetic disc, but the sectors of the same width can be represented from the starting of the disc, that is track, to ending of the track. So which makes the optical disc more better and convenient than the magnetic disc. So the optical disc examples are read-only, that is CD-ROM, DVD-ROM. Recordable includes CDR, CD-RW, DVD-R. CD-ROM is written on by the manufacturer of the CD-ROM using the laser light. CD-ROM is an optical disc that can only be read and cannot be written. CD-ROM drives read the data from the compact disc. Data is stored as bits and LANs. When the laser light is focused on the disc, the bits scatter the light and the LANs reflect the light to a sensor which is interpreted as 1. Since there is no head touching the disc, but a laser light CD-ROM does not get worn out easily. So the storage density of the CD-ROM is very high and the cost is low as compared to the floppy and the hard disk. So accessing time of the CD-ROM is less. It can read the data of maximum up to 150 kilobits per second. So they will come in a multiples of the speed like 2x, 4x, 5, 2, 4, 52 and etc. These are all the writing speed. It is a combination medium for distributing software and large data. So this is a pictorial representation of the CD-ROM. The next one, digital versatile disc or digital video disc. It's a DVD ROM. It's an optical storage device used to store the digital video or computer data. It improves on CD technology. It's a high density medium with increased track and bit density. So DVD-ROM uses both sides of the disk and special data compression technologies. Each side of the DVD-ROM can store 4.7 GB of data. So a single DVD can store 9.4 GB of the data. So new DVD-ROMs use the layers of the data track to double its capacity. Such dual layer disk can store the 17 GB of data. This is an example of a DVD disk. The next one is a recordable optical disc. That is a CDR and write only read many WRM disk. The next thing, compact disc RW, readable, rewritable, written, eraser and rewritten. Next one, digital video or disc recordable. It's a DVD device required to write the data and read the data. Once written on a DVD cannot be erased or changed. Magneto-optical disc, which uses a laser beam to read the data and magnetic field to write the data. So these are all the optical discs where the data can be written, erased and rewritten easily. So the magneto-optical disc costs expensive and they are outdated because now we are not using the magneto-optical disc. They were used in the mid 1990s. They have been replaced by CDRW and DVD-R now.